Welcome. So my talk will be GenAI for Web Developers. And first of all, before I start, I'm really happy to be back here at this conference. I was already here last year, and some of you already remembered me, so it's great to see some familiar faces, and happy to be invited back. A lot has changed in how we do software development or web development in the past few years. I mean, the way you write your Angular code or the way you write your code at all has been changing a lot. And this is mostly due to AI. If you think back what AI looked like a couple of years ago, so maybe in 2018, the first time this conference was held, if you asked someone about AI, they probably told you it's about using math, it's about using statistics, of machine learning, and most of all around writing Python code. And a lot of the things, so I've done a machine learning course maybe like 10 years ago, and basically everything we built was distinguishing muffins like blueberry muffins and tiny dogs. And they were using AI so much different. Because all of us are using ChatGPT or Bard or Gemini or how it's called today, or you're using GitHub Copilot to make you a faster or better developer. So all these things have been changing while we're still writing the same sort of applications. So before I'm going to deep dive into how you can use GenAI as a web developer, let me give you a short introduction. So my name is Roy. I used to be really into GraphQL as a technology. I still like it a lot, but the last few months or maybe last year, I was really focusing on what's going on in AI. I work at a company called IBM through an acquisition of my previous company. And in there, it's also great to see so many Indian developers I work with every day. I also wrote some books, and you can find talks of me on YouTube in case you're interested. And make sure to follow me on all the social media channels in case you have any questions after this talk. So for starters, I'd like to say AI has changed how developers write code. If I look at myself, it has really changed the way I write code. I use code assistants, I use ChatGPT, I use other forms of AI, I generate images or videos. So I'd like to see some hands from people who have seen their job change due to AI or change the way in which they write code. So who's using code assistants or ChatGPT or things like that every day? So quite a few of you. That's good. That's a good start. But then comes the tricky question. How many of you actually knows what's going on? So whenever you type in a question, do you know how it gets to the answer? I mean, I do, but maybe some of you will say they do. But a lot of you probably don't really know what's going on. You heard about LLMs, you heard about foundation models, but you maybe don't even know what's going on exactly. So in this talk, I'm mostly going to show you what's going on, sort of high over, but also how you can use JavaScript to create these applications yourself. So typically, if you interact with a AI application like ChatGPT, you will ask a question and you'll get an answer. If you're using a code assistant, you're maybe also asking a question because there's some integrated things there, but you might also be writing code that's sort of seen as the thing that needs to be answered or needs to be followed up. And a lot of things are happening in between. So whenever you type that question, before it will give you an answer, there might be some API calls, there might be some code executing somewhere, and there is a large language model figuring out what the hell you want. So you're asking a question, what should be the best possible answer? And I showed you what AI was in 2018. All those things will still happen. But the good thing about living as a software developer today, you don't need to know all these things because there's so many abstractions and so many things built on top of AI that made it easier for everyone to use. So today I'd like to say you don't have to be a data scientist to build AI applications. You don't need to know how to run Python or to train your own model, or you don't even need to know the statistics behind what's going on whenever you ask a question and it tries to find the answer based on a large set of data. The other thing you need to know are the web technologies that we already know. Like I said, there's JavaScript. Maybe some of you are building Python backends. That's a good start as well. But most of all, if you know how to use APIs, you would be able to use any of the AI things you see today in ChatGPT or GitHub Copilot without having to know how to build these models or without having to run these models yourself. And this is all due to foundation models. So these are the sort of large language models that you see today. And there's a whole range of foundation models. ChatGPT is based on their own GPT foundation models, of which there are multiple versions. And I think a good selection of popular large language models today are these ones. One I personally really like for code is Llama from Meta. It's really good at helping you to write code and making you, sort of write better code. The reason for it is because these LLMs are trained on datasets. And something that Meta did with Llama was they trained it on Python code or other sort of code that they saw within their organization, but also outside. And all of these LLMs sort of have their own specific goals. If you look at GPT from OpenAI, it's mostly like a broader model. It's able to help you with all sorts of questions. If you look at Llama, it will be a bit worse in helping you to find out the best places to visit in a city, but it will be way better in helping you to write code. So the reason why it became easier to build AI applications is that all these foundation models can be accessed through technologies you already know. So one of the more important ones there is LangChain, which is originally a Python library, but there's also a JavaScript version. It's using TypeScript actually, so it would probably fit into most of the tech stacks you're using today. OpenAI also has access to their own models through APIs, but also something called functions. And using these functions or APIs, you would be able to build whatever GPT or ChatGPT is showing in their application. And then also at IBM we have watsonx, which is also a platform to give you access to these foundation models through APIs and SDKs. And then of course, if you're building an application on top of AI, you need to use something like Angular or React or whatever is your favorite front-end framework. So today we'll be using Angular there. And the thing we can do is we can take what LangChain builds, abstractions on top of foundation models, and integrate this in our Angular application. As I said, it's all JavaScript, so it's not different from calling any other API or from interacting with any other library or functions. And of course, you need to set up some things. You need to have a API key to one of those foundation models, or not really the models itself, but the providers that provide access to them, and then you're ready to go. So this means that every developer in the audience today is able to develop AI applications. You might not know exactly what's the math behind what the LLMs are doing, but you're able to develop applications, and while doing so, you're going to learn a lot of things. And the only thing you really need to do is, in whatever type of application you're building, or maybe you're building an API in JavaScript, you can install LangChain just from npm. And by installing LangChain, you get access to OpenAI, watsonx models from IBM, I believe Claude is also in there, and a ton of others. So by installing one library, you can access all these foundation models. And the good thing also is most of them have free trials or free forever plans if you don't use them too much. But how to actually go from your question to your answer? There's also multiple patterns for that. The simplest thing would be just to send your question to an API that goes to the LLM and then returns something. That's really straightforward, but today I'm going to show you how you can tweak whatever is going to these foundation models to get better results. And there are multiple patterns. I'm going to highlight two. A small spoiler here is that the previous talk also showed the second pattern, more or less. So let's start with prompt engineering. So prompt engineering is the most common way to tweak the responses you get from an LLM. So maybe if you ask a question to ChatGPT, you ask, what is the capital of this city? That's one way to do it, but you can also provide more information there. And this is all being done through prompts. So the question you ask to the LLM, it will be translated into a prompt, and quite often the prompt is the same as your question. Because you're not doing any prompt engineering, you maybe don't have a template to optimize the responses. So a prompt is nothing more than a natural language text telling the LLM what it should do. And then prompt engineering is finding a better way to structuring this text in order to get the best possible results. A small disclaimer here is that prompt engineering can be different from model to model. So some models like you to use brackets in there, or they like you to use quotes, or they prefer a more natural language approach, whereas others have system tags in there that you should use. So I'm keeping it high level today because maybe you're not a prompt engineer yet, but you might be in due time. So most of the times when you interact with a LLM, you ask a question, the question will be put into a prompt, and this prompt might include some additional instructions. And this will be passed over to the LLM that will generate your answer. So it isn't as simple as sending your question to the LLM, although it could be, but you like to do some prompt engineering in between. So one prompt I like to show is, you can ask a LLM what the capital is of a certain city, of what are the highlights to visit, and it will give you an answer. But there's a way to personalize this. For example, you can tell the LLM to take the role of a personal travel assistant. Or maybe you can even tell him, take the role of a personal travel assistant from someone that has never visited Europe, or from someone living in India that's traveling outside of India for the first time, and answer the following question. The response you'll get should be different because it tries to tailor the response to the audience. And this is something we call zero-shot prompting. So there's all sorts of prompting engineering techniques. This is the simplest one. It's zero-shot. You give it limited amount of information and you just hope the first response will be good. And if you want to use this in a LangChain, it's only, let's say, 10 lines of code, maybe less. So you need to import the LangChain libraries, and we're using OpenAI here together with some core libraries that are present in LangChain. So you just import these after installing from npm. Then you connect to OpenAI, so you need to give your OpenAI API key, and as I said, they will give you some free plan if you sign up. And then you can create a prompt template. So a prompt template is nothing more than a string with some template literals in there more or less, where it would inject your question into this template. And in here you can do all sorts of things. You can tell it to take a certain role, you can tell it to give short responses or long responses, or maybe you can even tell it to reply with JSON or to only give true or false answers. So whenever you've done all this, the next step is to chain this. So you sort of chain your connection to the LLM with the prompt template, and you send it over to your foundation model. Through LangChain here, of course, because you don't need to write these connections yourself. So in 10 lines of code, you'll be able to do something that ChatGPT does for you, but now you're able to integrate this in your existing product. You're maybe even able to make a new product out of this. There's all sorts of things you can do just by writing these limited number of code, and without having to really know what an AI is doing. Of course, you have a better idea already, but you don't need to know exactly what's going on in terms of statistics or mathematics. Another example of prompt engineering, which is still quite basic, but it already goes a bit more into detail of what you could do. You can still tell the LLM to take the role of a personal travel agent, but this time you're going to give some examples of how you like the answers to be formulated. Because maybe you don't like the standard formulation of answers from ChatGPT. I normally don't, because it's either too lengthy or it's using too complex words. So for example, you can say, if I'm asking what are the best restaurants in Amsterdam, and it's a city where I live, you can tell it to explain in a list like this. So it should return the highest rated restaurants in Amsterdam are 1, 2, 3, and 1 through 3 would be transformed into names of restaurants. Similarly, you can also ask it what's the best time of the year to visit the Netherlands. So without these instructions and without this example, it might tell you that the best time of the year to visit the Netherlands is summer, and just summer, just the word summer, instead of giving you some text or some explanation, or maybe any sort of link to the audience you're reflecting to. So this is another technique that we call few-shot prompt. So here you already give some examples to the LLM, making it a little bit smarter and a little bit more tailored to your use case without giving it too much information already. So this is a good way to, especially in the beginning when you're just starting your prompt engineering journey, it's a good way to tailor the responses. And I have limited time today, but there's more examples you can do. So chain of thought, this is probably where you have you ask for follow-up, so you ask questions, and then you ask another follow-up question, and another one, and another one. So this will make the LLM better in generating the best possible answer, or self-consistency, react prompting, where it responses, it's a bit like reactivity, and also tree of thoughts. And this is one I personally like. So here you would give multiple scenarios, and then you try to figure out with the LLM what could be your best possible response. There's a QR code here that goes to a website called Prompting Guide, and they have examples of all these different prompt engineering techniques. But of course, being good in prompt engineering, asking questions is one thing. If you actually want to build something valuable, you want to make the LLM aware of your context, of your own data. So maybe you have data in a database, or you have data in your documentation. So something I see a lot in LLMs today is people are passing product documentation. So when we were just a startup, we were using our markdown files, which we used for documentation, and we passed that to an LLM in order to give answers based on those markdown files. But of course, you can pass all these markdown files in your prompt because it would overload the system. It might be too many tokens, and it might also be too expensive. So there's a technique called RAG, which is Retrieval Augmented Generation, and this is useful if you want to make LLMs aware of your own data. And this slide might look a bit complicated, but it's very close to the previous talk you saw about using MongoDB as a vector database. So when you ask your question, it creates embeddings based on that questions. Then it goes to your vector database where there is vectors stored of your data. And I'm going to show you how to get data in the vector database in a little bit. And then this vector database is going to be used for semantic search. So based on your question, which will be going through the embedding model, then it will go to the vector database. And in the end, it will give your prompt a few lines or a few paragraphs of data, which is coming from your own data set, and passes it into your prompt. Because like I said, if you pass your entire data set in the prompt, it's going to be either too expensive or it's going to take too long for the LLM to process. So we're using this vector database to turn our data set into smaller sets of data and only the relevant data. So if I ask a question about the highlights in Amsterdam and I have a data set that contains all major cities in Europe, it's only going to make sure that I have things that are about Amsterdam. And if there might be a city called Amsterdam, well, it could be included, but depending how you form your prompt, it should only get the actual city called Amsterdam. So it's going to take your data from the data set through the vector database. It's going to take your prompt and inject the data into the prompt together with your question, and then it goes to the foundation model. So this time the model knows about the recent data, it knows about your question and your prompt, and then it's going to give you an answer. So it's already a bit more specific. And the vector database is really the important thing here, because what we do there is we turn our data into smaller data sets. So we don't need to search through our entire data set, we're only going to search through smaller parts. So typically that means before you're able to do RAG, you need to chunk your data into smaller data sets. So you go from one large database dump to smaller sets of data, you store them in a vector database, and then you're able to retrieve them using semantic search. And even though this might look complicated, LangChain can do all these things for you in just a few lines of code. And all the other APIs and SDKs I showed, they're also able to do this. So if we look at our LangChain code, it's still straightforward. You import some libraries, you fetch your data. For now it's text, it could be Markdown, it could be HTML. You split the text into chunks, so you can see I have a chunk size, because the size of the smaller chunks of data you create can also impact the performance of both the speed of retrieval, but also the quality of the retrieval. And then you pass this to a vector database, and with LangChain you can even use a memory vector database. So if you're testing out things, this could be a good way to get started and see the results. It's going to take a bit longer to set this up efficiently, by the way, but well, whenever you're testing, it's a good way to get started. And then finally, you retrieve the relevant data sets from your data, from your vector database, and you pass them to the LLM, and then you would get the best possible answer. So I also have code examples for this, but I also understand we don't have time to go over all of these. And RAG is also not the only way to make LLMs context aware. Because as I told you in the beginning, the Llama model is really good at code, and some other models might be good for other purposes. Training or fine-tuning a model might be good if you have very specific asks of the foundation models that they don't really understand well. But it's also a trade-off, because training or fine-tuning a model is expensive, it will take a lot of time, and it might requires specific data. Especially building and training your own model is very time consuming, and it also requires knowledge of statistics and mathematics, whereas fine-tuning can be done in the same way as RAG is done through existing platforms. I wanted to look at code assistants a bit as well, but we already had a great talk that showed how to use code assistants. So I'm just going to tell you how I use them myself. So I use code assistant mostly to mock data. If I have one piece of JSON and I want to have more pieces of JSON, I typically tell GitHub Copilot to generate more. I use it to optimize existing code, but not too often because I still feel it could be a bit clunky. I use it to generate new code, and this is especially tests, because I don't like to write tests, and probably most of you don't either unless you're a tester. But also debugging. It could be really useful for debugging if you see errors in your code but you don't really know why. And I don't go to Stack Overflow that often anymore, so I either go to ChatGPT or I use GitHub Copilot. But to be honest, I'm actually canceling ChatGPT because GitHub Copilot does the same, and I'm not going to pay twice for the same thing. So I had some videos on showing you how to generate mock data, but we've seen something in the previous talk. So basically what I'm doing here, I'm writing one part of the data I want, and then just by creating a new line, GitHub Copilot is going to start showing us whatever we can add there. And then to write tests, so it's a very nice thing you can do. Just create a new file, call it something test.js, put your function in there or import your function, and just write a comment and say, write me a test. And GitHub Copilot will start generating a test case based on your function. It might not be the best test case, it might not get rid of all those edge cases, but it's going to save you a lot of time boilerplating this. So if you snoozed away during the talk, the short summary is building AI applications is just like building any other application. And the amount of knowledge you need is kind of limited because there's all these abstractions such as APIs and SDKs to give you access to AI. And the thing that really changed are these foundation models, because without these models, you would have to train your own model, or you had to pay someone a lot of money to get a model. So without foundation models, it wouldn't have been as easy to build AI applications today. So thank you, that was my talk, and make sure to say hi if you come across me. Thank you.